So let's put our hands together for Manav Gupta, Retail, Technical, Sales, and CTO of IBM Canada to the stage. Manav will be discussing IBM's approach to AI.
Thank you. Thank you very much. Morning. I hope you all can hear me okay. So I'm here to talk to you, in fact, take you all on a journey of unlocking the value or the promise of large language models within your enterprises. Now, in order to do that, maybe let's take a step back. Just want to test that the clicker is working. So let's just talk about how these foundation models that I'm sure you have all talked about, how they actually work. So it all starts by taking some data that exists in the public ecosystem. They're generally trained on public ecosystem. We go through this process called tokenization. So you take that data set, which is in a language, English, code, whatever it may be. You convert it into what's called a vector representation, which is geek speak for you're adding some numerical representation to that data. You can do this with image. You can take an image, you cut that image into parts, you put it through the same process. And effectively what you're doing is you're taking all of that data from the public sources, so whether it is Common Crawl, whether it is the public internet, all of the documents, US Patent Office documents, and so on and so forth. You take all of that data and you embed into a large language model, really into the neural networks or the multiple layers of a large language model. And at the very center of it all is these tunable weights, these parameters that absolutely define how you interact with these foundation models. You package it all together, and that becomes a foundation model. And I know some of this might be too fast and too much and too quick, but this is what our journey has been for the last 2 years, right? Everybody had an experience with ChatGPT, and then we had this whole new vernacular added into our lingo about things such as foundation models, large language models, number of parameters in a model, so on and so forth. But I thought, as I take you with me on this journey on what does it really mean for enterprises, and how do people like everybody else in this room, how can we truly unlock that value? So what I just gave you is a crash course that people spend months understanding how foundation models work. I've hidden some of the complexities of the various layers of neural networks, some of their activation functions, attention mechanisms, and so on. You can come catch me at the IBM booth if you're interested, and we can talk about where the world is going. Anyhow, so what we've done is we have taken large corpus of data, generally in public domain. We have collected it, we have curated it, we have deduplicated it, we have tokenized it, we have gone through that process, we have created a numerical representation of that data. We have done it in a way, we have now earmarked that data, and we have called it a foundation model or a large language model. And I'm deliberately using these two terms interchangeably, so anybody with a data science background, please forgive me a little bit, right, to take the liberty. Okay, so at that point, now let's talk about how do these foundation models represent your data. So I will submit to you that any large language model, any foundation model that you have used, they are all trained on more or less same data. They all start with what's called Common Crawl, which is last 17 to 20 years of data on the public internet. There is various ways that data can be acquired. They take that data, they put it through that entire neural network structure that I talked about, and I'll submit to you that it is the foundation models, they drive their power, this near human-like thinking that they have, they drive that power from the scale, because remember, these are billions, hundreds of billions, and now there is talk of trillion parameter foundation models. That scale and that vector representation into multiple layers of that neural network gives them this near superhuman knowledge or perception of knowledge. The connectivity, so similar to how neurons in our brains work, the neurons in this multi-layer perceptron, this multi-layer neural network, they fire differently. So when you ask it a question, write an email in Shakespearean prose as an example, it is traversing different parts of that neural network. Different neurons are firing in order to give you that impression of its inherent knowledge. And multimodality. So when these things started, everybody was working with language. English language, generally English, code as a language. Now we are starting to see different modalities of that data, and modality being the type of data, right? So language is one modality, code is another modality, images, audio are different modalities. And some of the foundation models or the modalities of data that the world is working on is things such as geospatial data, right? Things such as things such as financial data, and I'll show you some more examples of that. Now, everything I talked about, that is all data that is in public space. So that's all on your left, my right. That's all in public domain. And I will submit to you almost 100% of data that exists on the public internet, one way or the other, has made its way into a large language model from any hyperscaler, from any provider. But all of you, myself including, we all represent various enterprises. And for argument's sake, I'll say less than 1% of enterprise data is in that foundation model. Because enterprise data, and there was this beautiful panel discussion that we just had prior to my talk, that enterprise data sits behind the firewall in your data lakes, in your data fabrics, in your data swamps, governed with lineage or the lack of it. I'm not going to get into that religious debate right now. So what happens next? So the problem that everybody else has, and this is your mission, should you choose to accept it, is how do you take this massive power, this billion, trillion parameter scale large language models, and how do you apply those to your enterprise? How do you represent enterprise data? And I think one of the offshoots of the panel discussion previously was, how do they take the governance data, apply that to a large language model, or how do they use large language model to apply it to governance as an example? How can everybody in this room unlock the power of these really large neural networks and apply it to your data, in your enterprise, behind the firewall, with your governance? So your mission has 3 steps. I would submit to you that you should start, or we all need to start with a model that we can all trust, and I'll talk about that in a second. We need to figure out new ways of how do we represent data, some new representations like the vector databases, etc. And then we need to figure out how do we deploy these models at scale so that we can actually create value with this AI, so that we are not just simply consuming somebody else's AI, that we are creating value, we are being AI value creators ourselves. All right, so I'm going to break it down, and then hopefully, time permitting, I'll take some questions. Okay, so step 1, let's pick a model carefully. So I'll give you an example. If I was to give you a vessel, a glass of some sort, and it has some liquid, but this vessel, this container is opaque. And when you ask me what's in it, and I say, doesn't matter, go drink it. Odds are you will probably not be interested. As good looking as I am, you probably would not want to drink that. But if I was to give you a container that is see-through, you can see that it has clear liquid into it. You can see what the contents are. You can inspect the contents. You probably have a bit more confidence in consuming that liquid or that content. So you start with a model that you should be able to trust, that you have visibility into, so that you can understand what data went into training that model. And within the last 2 years, as I said, new words have added into our vernacular, things like hallucinations. Hey, my large language model is making stuff up. Or IP infringement. So I love this language model that I'm using, but then turns out it knows information that is copyrighted that it should not know. So I should be able to have attribution of content. I should be able to understand every data source that went into the model. Was this particular model that I'm using, was it trained on data that came from far-right websites, as an example? Does it have hate, profanity, abuse built into its content? So then you need to figure out those guardrails. So you take that trusted or that model that you can trust, that you have visibility into. You then add to it your own enterprise data. And I'll talk about some of the techniques that have emerged, and I'll submit to you potentially a new way of adding enterprise knowledge into those large language models. And then eventually, everybody in this room is then going to be able to take that data, take that large language model with your data that you can see, that you can trust, and consume it for your applications. Now, the base model, of course, you want this model to be transparent, but the transparency, the trust, shouldn't come at any compromise. So the base model should be performant. It should be equally or near performant to state-of-the-art, let's call them closed source models. It should give you broad commercial rights, so you should be able to build on that model, deploy that model to either create your new startup or monetize the service that you're building without being encumbered by restrictions of IP licensing, without the restrictions about having to submit back the enhancements that you've made into the model yourselves. And then finally, it should provide you indemnification from any IP infringement claims. So let's go. Let's get into this journey. So your first step, you start with a trusted model. So one of the things at IBM that we did is when we started on this journey about 3 years ago ourselves, we've built a series of foundation models that we call the Granite family of models, or Granite family of models for those from England. And the idea behind this Granite family of models is we decided to open source all of them. And apologies, the visuals don't show up. There is about 18 of these foundation models into 4 different categories. And again, you cannot see the text on the screen here. So there are these Granite models on language. So that's the stuff in under A. That's the third column. We have these Granite models for code, and I'll show you some of those code models. We have these models on time series. So that's to do with so far I've talked about foundation models that are related to language, but there is a class of enterprise applications that I'll broadly call the traveling salesman problem. So you're looking to optimize a resource. So think about, let's say you're a cruise ship line. You have multiple cruise ships. They have to make a decision on what's the most optimal route as they are navigating through the seas based upon current temperatures, weather conditions, size of the wave. How do they optimize their fuel consumption based upon the load on the engines, number of people on that ship? If there is a logistics company that has warehouses, what's the best route that the trucks should take in order to maximize the deliveries that they're providing? Any amount of any type of a resource optimization problem where you have a data set that changes over a period of time, that's called the time series model. So we open source a bunch of models around time series as well. And then finally, we worked with NASA and we open sourced some models for geospatial data. So these are models that are doing things like land biomass detection. They're detecting images on top of a land, so you can have appropriate zoning, as one example, weather prediction, etc. So let me just give you an example of where the industry is going. So the sweet spot of these billion, trillion parameter model, with some constraints, it all seems to be roughly around the 8 billion parameter size. I mean, that's a size where performance and cost and their accuracy all sort of meets at approximately that 8 billion mark. So here is an example of the Granite 8 billion parameter model. And by the way, within the Granite code families, we have models at 3 billion, 8 billion, 20 billion, 34 billion. The bigger you go, the more CPU, GPU horsepower you require, more your operating costs are going to be. But about this 8 billion model is the sweet spot. So this particular one was trained on 116 languages. So the graphic here that you see is a breakdown of the data set for different programming languages that went into training this model. And we trained it on 4.5 trillion tokens. And what's really interesting is that these models, while they were originally trained on perhaps one type of task, because of this sheer power and scale that they have within the representation of these models. These models are amazingly good at a wide variety of tasks. They can generate code, they can translate code, they can generate documentation, they can also do reasoning. So in this example here, you can use this for reasoning about, hey, how much time did my kid spend on a device? These are the activities that they did over a weekend, and you can change some parameters, and the model figures out the intent behind the question, and it can do some mathematical reasoning, even though that's not the core data set that this model was trained on. So here is a comparison, because I know the next question that I always get asked is, okay, all this is great, but how do you compare to other industry models? So what this graphic is showing you is a comparison of the Granite code model, 8 billion parameter model comparison on other industry peers on a wide variety of tasks. So what you're interested in here is the blue bar on the far right, and we're looking at comparing Granite with other models like the Llama 3, I'm sure that many of you are using, or Code Gemma from Google, and so on and so forth, on things such as, on tasks such as generating code, code explanation, code fixing, and so on and so forth. All this available under an Apache 2 license, by the way. Right? So I talked about the performance. So we published a paper earlier this year that's available on the public internet. I talked about the Granite time series models already. A unique thing about these time series models is that they're actually much smaller. So unlike the models in language and on code, which are multi-billion parameter models, for time series, they are actually few hundred million parameter model ranges. And they are surprisingly efficient at what they do. In the interest of time, I don't have a graphic to show you how they perform, but if you go to huggingface.co, you'll see lots and lots of examples on how you can use these models in your enterprise for your resource optimization problem. Here's an example of how this is a 300 million parameter model, the Granite time series TSFM, which in some cases is 600 times smaller than other models in the open domain. And its performance on a wide variety of tasks. So what you see on the right are, or your left rather, is examples like it's trying to predict how the fuel is going to be consumed given a certain parameters on a cruise ship, how a stock is going to perform on 0 shot, so without giving an example, or with a few shot example of training. As I said, we open source them all. So if you go to huggingface.co/IBM Granite, you'll find them all. Here they are. You can download them. You can run them in a trusted location of your choice using a model factory, model garden. For those of you that are more technical, if you're using any of the Python SDK, Node SDKs, whatever, you can consume those like any other foundation models that you're using in your enterprise today. Okay, so we started with a trusted model. This is a model where you have full visibility into the data set. We give you IP indemnification. You have full transparency into the filtering that went into building that model. Let's now talk about how do you take this trusted model and how do you add your enterprise's data into it? So what do? So in the last 2 years, I'm sure many of you, I hope all of you, have heard of this emerging techniques called RAG, which is short for Retrieval Augmented Generation. The idea here is I build this LLM, this model, which has understanding about English language, let's say, or French. But this model does not know anything about my enterprise. Whether it's healthcare, the discussion that we had previously, whether it's a financial institution, whether it is public sector, and so on and so forth. Maybe I have a policy document about insurance claims, and so on and so forth. So what do? So there is a whole cottage industry that started around retrieval augmented generation, where the idea is you take your enterprise data, and you'll create new representation or new vector representations. So I'm sure I see some of the folks nodding. So you end up building representations of that data into what's called vector databases. So you create this new representation, and you give that data set to this neural network, to the large language model. But there is a catch, there is a problem. apart from the additional cost and new dependencies that you've added, you're fundamentally not leveraging the scale of the large language model. Yes, you're giving the model this new context, this new data set that the model did not know. But the base model that you got, that you invested all this money and time in, it is not represented, your information, your knowledge is not represented into that base data set. There are other techniques. So you have something called fine-tuning, and I know it's a bit more technical, but the idea here is you can train the model, you can take any large language model in the open community, and you can train the model through a process known as fine-tuning, and there are various derivatives of that fine-tuning, to make the model really, really good at a specific task. That task could be customer acquisition, could be claims processing, could be answering on your help desk, whatever, right? The model becomes really good at doing that task. But the downside there is the general knowledge, the general representation of knowledge that was there in the model, you end up losing that. So you gain some higher accuracy, fidelity into a specific task, but that comes at a price. The other problem that happens is every time you fine-tune a model, you have basically created a new model. So some people in the industry like to call it the problem of the 1,000 llamas. Every time you train a llama, you create a new llama. And that llama becomes your baby for the rest of your life to manage. So we at IBM, we have invented a new methodology. And I'll show you what that looks like. The idea here is we have come up with a taxonomy-based approach to add new knowledge into a large language model on a data set that it previously did not know and did not have access to, that you can use without compromising, without jeopardizing the general knowledge that the model already had, that it came baked in. And really, it's a very intuitive method once I start talking about it, because we're trying to mimic how humans learn, how we learn ourselves. So this approach we call Instruct Lab. We actually open sourced it about a month ago. And the idea here is that we build our taxonomy. And I know the graphic is horrible, but the idea behind this is if you think about any human knowledge augmentation, any new skill that we learn, what do? We generally create some kind of a tree with a mental model, a mind map that we create in our own minds. Some people do it on paper. Sometimes we just do it implicitly because that's how we learn. So in this example here, I'm creating a new skill. Let's say it's for writing email in prose, could be worse, on what the email standards, what the writing standards, or whatever might be in my own organization. It's a banal example, but it gets the point. I'm adding new information into the model. So what you do is you basically you run Instruct Lab, you basically create this taxonomy. You take the base model, the granite models as an example. You take those models, you create a file, which is a YAML file, or which is a text file, with this new data, with this new information. You find a gap in the taxonomy, and within that taxonomy, you add a new skill for your enterprise data. It's as simple as that. You give that data set, you submit that request. That request through this Instruct Lab process goes to the back end, all within the watsonx platform, and I'll talk about the platform in a second. That's it. There is no other magic required. At that point, you have submitted new information into that model, and you only need to provide a handful of examples. So in this example, you provide, let's say, 3 new examples. Instruct Lab then comes with what's called a teacher model. So we then use another large language model to generate some synthetic data. So you give it 3 examples, we'll take those 3 examples, we'll maybe create 100 examples, and then we'll test the model. We'll go through a clever technique to add more training data into the model. And then you can iterate over that if you so wish, and you create a new model. So that model now is rubber stamped, that's yours, that's in your environment. Meanwhile, the open source community keeps submitting new requests on a daily basis. We do a weekly build, a weekly release of a new version of Granite. All you need to do is pull that data back. And that's all that's required. So this is all theory. Is it really practical? Is it really working? So within IBM, here's an example. So when we were building our Granite code model as an example, so we came up with a problem. We wanted to teach this model the COBOL language. Of course, the COBOL developers are no longer around. Those that are around are maintaining code. And what we really wanted to do was teach this model how to convert COBOL to Java, so modernize the stack. So what did we do? We effectively ended up hiring or training existing programmers to write COBOL. So in this scenario, we took some 500 skills of how do you write a COBOL program, the various instruction sets, etc. And we're basically trying to add into the LLM through the training process. This is before Instruct Lab. We are trying to teach the model how do you take COBOL and how do you convert it into Java. And we generated some 200,000 examples. Before Instruct Lab methodology, it took us 9 months and about 14 different iterations to get to some level of accuracy. This is all happening about November, December timeframe over Christmas holiday season last year. And that's about the time our lab was working on this new approach, this Instruct Lab-based approach. So we thought, okay, hey, could we do an experiment? Could we take that Granite model? Can we use this Instruct Lab approach and see if we add this COBOL knowledge into this model? Can we do it faster? Is it really going to be better? And you see the results. What took humans and the earlier approach, the traditional approach, 9 months, we were able to accomplish that in less than a week with just one iteration, with 97% accuracy. Okay? We also open sourced Instruct Lab. So if you go to github.com/Instruct Lab, you can download that and you can start playing with that. All right. So in our mission, we've gone through finding a model that we can trust. We've figured out ways of adding new knowledge into the model that it previously did not have. Now it's the matter of how do you scale that? And there are various ways of how you can deploy AI within your enterprise. But within IBM, we asked ourselves, what's the most efficient way? What's the simplest form factor in which we can democratize access to these LLMs, to these large language models, this entire methodology that I talked about? What we eventually concluded is we have to empower every developer globally. They should be able to run these models without requiring GPUs. They should be able to run these models on their own laptops if they wish to choose. So in July, we are going to be releasing RHEL AI, or Red Hat Enterprise Linux AI. And what's going to happen is, within that single developer bootable, that's going to come with Granite models with indemnification that I talked about, as well as Instruct Lab. So it's true scaling of technology, of the capabilities within RHEL. Now that's within a developer's laptop. If you want to scale it for slightly further, you can go towards OpenShift. So OpenShift, for those of you who don't know, is a enterprise Kubernetes platform. So it provides a common backbone for Kubernetes. You can scale it for workloads for your enterprise. It comes with things like resource optimization, model management, being able to manage GPU clusters, and so on and so forth. And then on top of that, if you so wish to choose, we provide our Watson X platform that comes with some guardrails around model monitoring, bias and drift detection, model performance, AI assistance, full governance of the AI lifecycle. So that's the mission. I'll leave you with one final reflection, and then I think we still have some time, so I'll invite some questions and commentary from the audience here. I will submit to you all that as the world gets polarized and the world evolves either to state-of-the-art closed source models or the open community-based models, for all of us To create and derive value from AI, AI has to be open. We all have to become AI value creators and not just consumers. The world at large is going to go forward. Our communities are going to prosper only if we all become AI value creators ourselves. And for that, AI has to be open. So with that, I hope you got a little bit of sense of where the industry is going, and I'll take your questions. Thank you.
Thank you so much, Manav. Any questions? Yes, right here. There's a mic. Thanks.
I think we have a runner with a mic.
Hey, thanks. I wonder if you could speak a little bit about, you talked about guardrails for the large language models in terms of the data it's ingesting. I wonder if you could speak a little bit about what guardrails Granite put in place.
Okay, so the question is around guardrails within the Granite models, and in general, if I expand that slightly, what type of guardrails should we think about when it comes to large language models, right? So look, the risks with AI, some are the older risks that have always remained, and there are some new risks. So within traditional, or let's call it predictive AI, there are risks around lack of explainability, lack of trust, clarity of lineage of the data that went into that AI model. With LLMs, some new risks emerge. So things such as hallucination, things such as prompt injection attacks, new types of attacks, adversarial attacks, etc. So within Granite, we have taken a two-pronged approach. One, we provide you full visibility into the data set that went into training the model itself. So the data processing pipeline, the data filtering pipeline, the content that was removed during the deduplication process, you have full visibility into the lineage of the data set that went into the model. In fact, we had clients come to us and say they wanted to take that entire data set and consume it as a service. So we ended up building a whole new product out of that. So that's one approach. The other thing is, how can we monitor the LLM and determine its performance? So there is a lot of industry benchmarks that have emerged over the course of last, I'm going to say, 2 years. So there is the Helm benchmarks, the Glue benchmarks, and Blue scores, and so on, Rouge L scores. So we provide you out-of-the-box capabilities to monitor your LLM performance. We also provide you a set of facts. We call it our AI fact sheets. All of the points that went into building and deploying that model for your use case within your enterprise. So which users worked on it, what kind of data did you use to fine-tune the model if you were fine-tuning it, or pre-training the model, what use cases what that model was deployed on. And then we provide out-of-the-box support for content indemnification, as well as attribution. So whether it is Bill C-27 in Canada or the the EU AI Act, does the model conform to those regulations? Does it leak any PII data? It's an endless list. If you come to the IBM booth, we can give you a demo of that. Okay? Any other questions?
We're actually out of time. I'm so sorry. We have another panel.
Thank you. I'll be there if
so
you have any
much.
more questions.
There you go. He's offering him to you guys after.